Thank you very much, Didert. Good afternoon, good morning, or good evening to our audience, which I see is coming from around the world. Thank you very much for your interest and for inviting me to this series of webinars. And thanks very much to the Odyssey Mur project and, of course, the European Commission, who has funded it in consecutive years, which has provided much expertise and also much support for our work. My focus will be on applying this principle at national level. I will start with using Cyprus as a case study because we have worked on this, but my focus will try to be more broadly on the challenges and on the application of this at the European level. It is a little bit inevitably a Eurocentric presentation because the energy efficiency first principle is embodied in the European legislation. So I think the first notion about this principle was included in the regulation of the so-called Energy Union governance in 1990, under which the member states had also the obligation to prepare national energy and climate plans. Essentially, the regulation is of 2018, right, of the year 2018. And there was a little bit more guidance more recently, last September, in a Commission communication on what energy efficiency first means. This is one of the definitions. It means that taking full consideration of security of supply and market integration, only the energy needed is produced in a country, and that investments in stranded assets can be avoided in the pathway to achieve the climate goals, essentially to achieve climate neutrality by the middle of the century. And this principle is also a key principle in the renovation wave strategy that the EU also announced last year, and of course should be part of the national long-term energy renovation strategies that are also a part of the obligations of EU member states. Now, this means that all countries in the EU have to give priority to cost-effective measures reducing energy demand before other interventions towards reducing carbon emissions are adopted. That's another way, perhaps, to define the energy efficiency first principle. And an important clarification, again, in EU guidance is that to apply this principle, we should use a societal perspective when analyzing which measures are cost effective. But of course, at subnational level or at the level of a company, for example, the implementation decisions should look at cost effectiveness from the investor's perspective. Since what I will be presenting will have to do with national policy, we will apply this societal perspective, taking into account also multiple side benefits of energy efficiency measures. Now, more recently, last July, the European Commission published a series of proposed changes in EU legislation, among which also changes in the Energy Efficiency Directive and in other directives that affect energy efficiency. And this recast Energy Efficiency Directive reinforces the principle, saying that member states in this case shall assess the application of this principle annually where major investment decisions are subject to approval, and identify also the entities in the government that are responsible for monitoring the application. And it's not only the central government necessarily, it's also the electricity and gas transmission and distribution system operators, which must apply energy efficiency first in their planning and investments. Now, this means that there must be a substantial amount of work or evidence that should be provided in order for a country to report that it respects or takes into account the energy efficiency first principle. We have been working with the national energy and environmental authorities in Cyprus for some years now, providing different models that were used in different kinds of policy assessments. And this sort of flow diagram, although not very precise, has on its left-hand side the different models that we have developed over the years, and on the right-hand side, the different uses of these models for different policy assessments, which had to do with cost-optimal decarbonization pathways, energy projections, identifying the energy efficiency potential, macroeconomic impacts, and so on. To become more precise, we have provided, and we are providing still, model-based support to national policymakers. We have contributed over the last decade to the preparation of consecutive national energy efficiency action plans. Together with the German International Cooperation Agency, GIZ, we identified the theoretical but also the economically realistic energy efficiency potential in different sectors. We conducted the impact assessment of the National Energy and Climate Plan of Cyprus, which is part of the formal obligations of the government. And today we are providing scientific support to governmental authorities, several ministries, for all aspects of the European Green Deal that have to do with energy, climate, and transport policy. We support the electricity authorities for their electricity forecasts, which lead to security of supply estimations. And we will also support in the coming 2 years the government for the preparation of the updated National Energy and Climate Plan, a draft version of which has to be submitted to the Commission in summer 2023. Which means that we are building the knowledge base for the energy transition through the development of energy system and economic models, identifying energy efficiency potential, and also prioritizing or assessing the cost effectiveness of different emission abatement measures. And all these feed into the impact assessments of the National Energy and Climate Plan and related strategies. And this includes the energy efficiency first assessment. So on the basis of the studies that we did in the past, we were able to identify cost-effective energy efficiency measures and cost-effective carbon emission abatement measures more broadly. This is just an example of summary tables that we were able to prepare over the years with the aid of more detailed models of the building stock, but also of transport and so on, that include a variety of emission abatement measures, carbon emission abatement measures, which includes data estimations or calculations or projections of the total discounted costs of each measure or policy, the emission savings, greenhouse gas emission savings, creating a cost effectiveness index, and also identifying the potential to reduce emissions. In this framework, of course, a major part of these emission abatement measures have to do with energy efficiency measures. For example, this is just an example, in the residential sector, on the basis of surveys of detailed data and some detailed building energy models, we were able to identify some reasonable measures that are listed here on the left-hand side for energy renovations of buildings, for buildings of different cohorts or different ages, depending on when they were constructed. So we obtained different data, we aggregated them in order to arrive at some meaningful classifications. We classified also the buildings according to the construction period, depending on whether energy performance requirements were in place or not. We calculated cost and energy saving data for each one of the individual measures. We identified the main technologies that are used, especially in buildings in this case, since the slide is about the residential sector. But what is also extremely important is we tried to identify, with the aid of market data, but also with the experience of the authorities, the potential of each measure, which means the number of interventions that are realistic to implement, in this case for residential buildings, up to 2030. This is just an example of different energy and cost data for residential buildings for a specific building cohort here. For example, for this case, for buildings built before the year 2008, in order to identify as you can see here, to identify cost and energy savings potential for the different kinds of measures. We don't have to go into these numbers now. That's just an example of the kind of data we collected, together with some more technical data about the different heating and space cooling systems for different kinds of buildings and different ages of the building. And what I explained as important is also to assess the potential. And this was an estimation which we did together with the GIZ, as I said, some years ago, on the potential to implement different kinds of energy renovations up to 2030, keeping into account both financial constraints, but also practical constraints, and also constraints as regards the degree of realistic application of different measures in different kinds of buildings. For example, multifamily buildings may be more cost-effective to renovate, but they are more difficult to implement because several families, several homeowners have to agree with that, and so on. And that was an example about the residential sector, but we did similar assessments for the sector of tertiary buildings and similar assessments also for agriculture, for some renovations in the sector of agriculture and also in transport. What we ended up with in the first place was something like this, so-called marginal emissions abatement cost curve, which on the horizontal axis shows the potential reduction in CO2 emissions or in greenhouse gas emissions, and in the vertical axis we have the unit cost the cost of each measure per unit of emissions abated. So the horizontal breadth or the width of each one of these rectangles corresponds to the realistic potential to reduce emissions. So it corresponds to a number of buildings that can be renovated according to this or that policy measure. And obviously, most of the measures which are deemed to be cost effective with theoretically negative abatement costs have to do with energy efficiency measures that have to do either with improving thermal insulation or roof insulation, or installation of heat pumps, or even with cogeneration. But what we also took into account, and this relates to one of the requirements of the energy efficiency first principle, was to reassess the costs, taking into account also the avoided external costs because of the avoided emissions of greenhouse gases and air pollutants, and based on the external costs related to the emissions of three major air pollutants: sulfur dioxide, nitrogen oxides, and particulate matter, but also of greenhouse gases, taking into account the social cost of carbon. So one could say that this assessment includes this societal aspect, looking into broader benefits because of avoided air pollution. Now, of course, this marginal abatement cost curve is something static. We expanded this work later with dynamic models that take into account the changes in the costs, in the potential, and so on. But in any case, this is just a snapshot of results from our different modeling studies, which we could then use when we were preparing the impact assessment of the National Energy and Climate Plan of Cyprus, to address also requirements related to the energy efficiency first principle. So how we used these results? Advising the government, the National Energy and Climate Plan included in their planned policies and measures scenario that is part of the NECP, all those energy efficiency measures that we have calculated as clearly cost effective. And we put special focus on sustainable mobility measures, because this is a very crucial topic to achieve decarbonization for non-ETS CO2 emissions, but also in energy savings. We included cost effectiveness and cost benefit calculations, such as the one that I showed you just before, but many further ones. We included this in the impact assessment of the NECP. And as you probably know, the impact assessment was the mandatory Chapter 5 of an NECP that a government had to submit to the European Commission. Another way to say that our work and the measures that were included indeed addressed the energy efficiency first requirements was that the measures that were included in the PPM, the Planned Policies and Measures scenario of the NECP, which were largely based on our results, were sufficient to meet the national energy efficiency directives obligations. There were additional stronger energy efficiency measures that were not part of the NECP. You could say because the NECP was not very ambitious, but also because the EU policy at that moment, but in 2019, was not as ambitious as it is today. So energy efficiency measures that, according to the analysis, had quite high costs were not included. And addressing also a part of the guidance on energy efficiency first, which includes to internalize to the fullest possible extent the costs of energy alternatives. The NECP, based on some of our calculations, kept as a Okay, now again. Following the guidance on the energy efficiency first principle, which is to include considerations how to internalize the environmental and climate costs of different energy policy measures, the National Energy and Climate Plan, based on some of our calculations, included carbon pricing as a reserve measure. It was not necessary to meet the targets of the Energy Union governance regulation, but it was included as in background calculations and was ready to be used. So what I said before was that we were more or less in line with this provision of the energy efficiency first principle as well. Now, meet the national energy climate plans, we are now in an environment with much more ambitious energy and climate targets in the frame of the European Green Deal and the European Climate Law. You know that the European Green Deal was adopted by EU leaders at the end of 2019 and has set the EU, apart from other aspects that had to do with other environmental issues, it set the EU on a path to net zero greenhouse gas emissions by 2050. And now this target has become legally binding for all EU member states through the European Climate Law that was adopted in July 2021. In July, in the same month, this Fit for 55 package was published by the European Commission, which includes several proposals for changing all energy, transport, and climate-related legislation with ambitious targets on energy efficiency, on penetration of renewable sources, on emissions subject and non-subject to the emissions trading system, on a new emissions trading system, on sustainable fuels in shipping and aviation, and so on. So we are in a new policy environment, and in this policy environment, the energy efficiency first principle has explicitly become more prominent, and it now has a more clear institutionalized role, where, as I mentioned in one of my first slides, governments must declare to what extent they have taken this into account. Gas and energy regulators and transmission and distribution system operators must take this into account before major investments are conducted, and so on. So what is going on now? How can we address energy efficiency first in our era, in the era of the European Green Deal? I'm providing some thoughts, and which are based on some results of studies that we conducted during the last 2 years. I would say that first, at least in this era of the European Green Deal, we also have the EU Recovery and Resilience Facility that was decided in 2020 and started being in operation in 2021 as a post-pandemic additional recovery measure at EU level. But we also have the new regular EU budget for the period 2021 to 27. So we should assess the energy saving potential of current budgets and also medium-term investment plans. And these two, the recovery facility and the regular EU budget, are medium-term investment plans for EU member states, but also the annual or tri-annual national budgets are also part of this. So we should assess the energy saving potential of different measures and to check at the first site whether these plans, these budgets and investment plans are sufficient to meet national targets for 2030, the new national ambitious targets related to energy efficiency and greenhouse gas emission reduction. To the extent that these may not be sufficient, to explore additional measures, additional energy efficiency related measures as regards their cost effectiveness, and of course identifying both the economic but also the environmental co-benefits, ideally also other co-benefits, which may be, however, a little bit more difficult to quantify. This is an example of a study that we conducted before formally the EU recovery plan was implemented, together with economists from the World Bank and the UK, where we explored the cost effectiveness or the environmental and economic effectiveness of different recovery measures, green recovery measures. And we compared these with a black dot in the middle of this graph, which shows what would be the combined effect of the economic multiplier and the employment multiplier. So the effects on growth and the effects on jobs of a uniform economic stimulus, which would not take into account environmentally relevant measures. And what is interesting to see, and you can find more information and more graphs in the related report that I have listed here, is that if you just stimulate demand in the economy in the sectors that are in the sectoral shares that are currently active, this is not only environmentally not proper, but it is also not the economically optimal solution, because there are many energy efficiency related measures that have higher economic multipliers and higher also employment benefits. These assessments have been made with the aid of very detailed national data on the basis of our models, but on the basis also of additional data that we collected that had to do with the value added of different sectors, local employment changes, and so on. So this is one way to address additionally the energy efficiency first principle, identifying measures that would be worth including in the medium-term investment plans if they have not been included up to now. Apart from these points, the next point is to understand clearly. Many governments have already done so, but sometimes implementing such policy measures is not extremely straightforward. To understand the need for early action in order to achieve carbon neutrality by 2050, which we have to remind, always to remember that now it's legally binding in the EU. So it's not just a wish list, it's not just a good target to have. Carbon neutrality is legally binding already now. So we need to understand the need for early action to avoid what we call carbon lock-in, and energy efficiency measures have a very significant role to play in this case. This is a way to put this visually on the basis of some modeling work that we did 2 years ago. You see the green line does not reach zero greenhouse gas emissions because climate neutrality was not a clear policy objective by 2018, 2019. But consider the green curve to be something like the pathway to climate neutrality. And we have other scenarios with higher energy demand, primarily, which move us away from the zero emissions target. And what is the notion here? What is the meaning of the carbon lock-in? That obviously, when we have higher energy demand in the years to come, in the first years to come, already this decade, then we need to adopt more carbon-intensive investments today, which will have to be phased out relatively soon. So this can lead to stranded assets, because one will not only need to have stronger decarbonization afterwards in order to correct the path, but will also have to live with stranded assets, because these high carbon intensive investments that may take place in the coming years to satisfy a growing energy demand or a stagnant energy demand will have to be abandoned perhaps before the end of their lifetime. Imagine a new power plant, a new fossil fueled power plant that has to be built very fast to meet energy demand, and taking into account their lifetime, it should not be used at all in 20 or 25 years' time in order to reach climate neutrality by 2050. So this importance of early action is an extremely useful concept, and it's not only, of course, a concept, it has very practical implications, but it is important to highlight this to policymakers, because obviously what is not necessarily seen as urgent policy may be postponed for later. And if we remember that the climate neutrality target is legally binding and we cannot escape from this, then investing later will mean higher costs. So, and the final point on these issues, how to address energy efficiency first in our current era, is to identify the challenges in implementing all these energy efficiency investments. For example, we have this renovation wave strategy that should implement a huge number of energy renovations in buildings and in other economic sectors around Europe. And this can be very well addressed in models and in policy declarations and in long-term strategies. However, now we have to move to the implementation. And what the Fit for 55 package overall and also the climate neutrality target means is that we need investments at unprecedented scale and at unprecedented speed in order to be able to reach the climate neutrality targets. If the climate emergency did not exist, it would certainly be a folly to think that within 25 or 30 years we can reach net zero emissions. The problem is that it seems that climate emergency is a real threat to our livelihoods, and that's why we need to act fast. But acting fast means to go to the implementation of all these investments. And it is an open question to what extent we can really realize the renovation wave at the same time around the whole of Europe. And of course, keep in mind that there are many countries around the world that are talking about climate neutrality, and some of them have also legally adopted this. So it's not only Europe. So it's a matter of financial resources, but it's also a matter of human resources. To what extent we have the personnel in all EU member states, some of which facing serious demographic issues, to implement all these investments. So this is also a part of the energy efficiency first principle, because we should also show that it's not only taken into account, but it's also implemented. And that's also a challenge. So to conclude, I would say, and distancing myself a little bit, hopefully, from the case study of Cyprus that I have talked to you about because we are familiar with it, I would say that to address energy efficiency first at this point in time, we should consider questions such as whether the energy efficiency measures that we adopt in a strategy can substantially reduce energy demand compared to a baseline, because if they are not very effective, then probably we are not addressing the principle very properly. To what extent the policies that a country implements are sufficient, first of all, to comply with the legal obligations, for example, with the proposed revisions of the Energy Efficiency Directive and other national and European legislation. To what extent the national strategy contains all cost-effective policies that are related to energy efficiency, and whether there is scope for further energy efficiency measures, and if someone answers with a negative, gives a negative answer, one should be able to justify why there is no scope for further measures. To what extent energy and carbon pricing measures have been considered, to what extent the cost effectiveness calculations in order to determine which energy efficiency measures will be included in a national strategy take into account societal benefits, and not only the lower energy costs because of energy savings, but also improvements in air quality or in security of supply, or even issues of social equity, which relates to energy poverty, of course. And not to forget possible risks or barriers to the implementation of measures. We have been talking about the barriers to implementation of energy efficiency measures for decades. Financing obstacles, barriers in human resources, behavioral issues, and so on. But now, at a time when, as I said, we need investments and action of unprecedented scale and speed, we are even more prone to delays because of such barriers. How will this be addressed to avoid having falling back on the energy efficiency first principle? Obviously, as an academic, I would just say that we need an adequate knowledge base with national data and with appropriate modeling tools that will not necessarily have to be very elegant mathematically, but they have to be sufficiently accurate in order to be able to respond to the proper policy questions. These are some references that on our work that you can look into later on. I would, of course, like to thank the European Commission, the Horizon Programme for the Odyssey Mule project, of course, but also the European Commission's DG Reform, which has supported some of our studies over the years, and the government of Cyprus, and especially three ministries, the one of finance, the one of energy, and the one of environment, which have supported us or have provided us with information and hopefully have adopted some of our recommendations. Thank you very much.